10 seconds to settle down, otherwise you will remain standing. 9, 8, 7, 6, 5, 4, 3, 2, 1. You can remain standing. Who is this is red? Okay, now fine. Yvonne and Wei, tell me figure out who are the missing students. Okay? Then tell me at the end of the lesson, okay? Okay, sit down. Now, I want you to do your self-marking for worksheet 6C. We have already gone through most of this. Mr. Tan's class has already gone through this. So you will just follow first. Okay, then you just listen. Come in. Has Mr. Tan gone through these answers with you? Yeah. Okay. So, my students, any questions on this page? Okay, continue on self-marking. Questions 4 and 5. Settle down quickly. There is one child here. Okay, I'm not going to go through this portion because we went through it the previous lesson already. Now, the car is traveling at 36 kilometers per hour. We are asked to calculate the kinetic energy. All moving objects, they have kinetic energy given by half mv square. Mass is given in the earlier part of the question. Velocity, in this case, because your energy will be in joules, so your velocity must also be in SI units. You need to convert 36 kilometers per hour to meters per second, which was done earlier on also. So use the correct values. And then we can compare the total energy before and after. We realize that finally the energy is less than what was originally the case. And can we conclude that energy was destroyed? Can we conclude that energy was destroyed? Cannot, right? Why? What's the law that you learned? Or the principle? Principle of conservation of energy. Energy cannot be created, cannot be destroyed, only can be converted from one form to the other, to another. So you need to memorize this. Okay, so energy was lost. Where was it lost to? It was converted to heat or thermal energy in the brake pads. That is when you step, you want the friction to be there to slow the car down. Okay? Next, a motorcycle accelerates uniformly. Converting units, can do it. Acceleration. Acceleration is given by your final speed minus initial speed divided by time taken. 2.5 meters per square second. Part C, we want the effective force, meaning we want the resultant force that is acting on the motorcycle. And our resultant force is given by F equals to Nadia? F equals to ma. So mass given, acceleration calculated already. So 1000 newtons is the effective force acting on a motorcycle. So since we have the effective force and we have the distance traveled, we can calculate the work done. Force times distance moved. Yes or no? Yes. Yes. Are you from my class or not? Huh? Are you from my class? So force, work done equals to force times distance moved. Yes or no? Can don't throw my face. Afiq, are you in my class? Okay, what is work done given by? What? Force times? Force times direction. Oh no! Okay. Let me try. Somebody from Mr. Tan's class, can you raise your hand and... Yes. Hurry. Yeah, okay, hurry for our class. Now, you better save our face, huh? What is work done? Force times direction move. One more time. Say it. Force times. Did he say perpendicular distance? Okay. Never mind. Can I have somebody from Mr. Tan's class to share? Shofi, are you in Mr. Tan's class? Okay, never mind. Let Shofi, yes. Force times. In the direction of? Okay, the work done is given by force times distance moved in the direction of force. Okay, Gaius? It is not the same thing because you can be moving in one direction but the force is in another direction. Now, over here, because the work done, the force and the distance moved is in the same direction, we just simply multiply them together. Okay? Then, when the motorcycle was at rest, there was zero speed. So, no kinetic energy. Then, when it is moving, it had a kinetic energy of 8 times 10 to the power of 4 joules. So, what is the gain in kinetic energy? It will be the final kinetic energy minus initial kinetic energy, which is the same one, 8 times 10 to the power of 4 joules. So, answering this question, the gain in watt of the motorcycle is the result of the work done by the force in moving the motorcycle forward. Since your energy cannot be created, it cannot be destroyed, it has to be converted from one form to the other, this kinetic energy must have been provided somewhere. And it is provided by the force, the effective force at part C. This force provided the work to be done, provided the energy for work to be done. Okay, so kinetic energy is a result of work done by this force in moving it forward. Any questions? Okay, then 6D. Gravitational potential energy is possessed by a body due to its position above the ground. It must be a certain height above the ground in order for it to have gravitational potential energy. Is that a problem, Jovia? Within? What is it that you're asking him? Is it related to physics? Yes or no? You shake your head, then you nod your head. So yes or no? Yes, sir. Okay, then I'm very interested in the question. What is the question that you're asking him? He tell you already. Jovia, what do you tell him? About physics. Jovia, what do you tell him about physics? Formula for work done. Was that it, Waylin? Okay, better be, Okay, so formula for gravitational potential energy is mgh. You notice that as the mass increases, the gravitational potential energy increases. As the height above the ground increases, your gravitational potential energy also increases. Then this boy, he picks up a piece of chalk from the floor, places it on the desk. The mass is 0.008 kilograms, which is already in SI units, which is good for us. And the desk is 0.9 meters from the floor, also in SI units, good for us. And gravitational potential energy of the chalk, when it is lying on the floor, is 0. So when I raise it up to 0.9 meters above the ground, it now gains gravitational potential energy of mgh. Okay, that will be found at the bottom. Part 4, mgh. So instead of just calculating the gravitational potential energy, we can also find out the weight, which is mg. G is given to be 10 meters per square second or 10 newtons per kilogram. Multiply it by the mass to get the weight. If you want to lift a piece of chalk up, you need to provide a force that is at least equal to the weight. That's why when you want to lift something heavy, you need to provide more force. You are trying to counter the weight of the object. So in this case, the force to be applied will be the same as the weight of the object. If you apply a greater force than the weight, then the object will accelerate upwards. If you apply a force that is smaller than the weight, then you will stay on the floor. So work done, force times distance moved in the direction of the force, which is upwards. You get 0.072 joules. And you realize that, hey, it is actually the same as the gravitational potential energy when it is on the desk. Because the amount of work done, 0.072, the work done was to lift it up to a height of 0.9 meters. That is why the potential energy, gravitational potential energy at 0.9 is the same as the work done. So now, he's going to lift it up another 0.2 meters. The work done in lifting it up is again force, which is the weight, times distance moved upwards, 0.016 joules. And finally, gravitational potential energy, when it is on top of the books, will be mgh. Now h is not just 0.2, it is 0.9 plus 0.2. So that gives you 1.1. So finally, it has a greater amount of gravitational potential energy than on the floor, than on the table, because it is now higher. Any questions? So now, deduce the change in gravitational potential energy is just a subtraction. Okay? From the top of the pile of books minus the gravitational potential energy when it is on the desk. So this is the amount, this is the change in gravitational potential energy. Where did this energy come from? Who provided it? Who provided this energy? Yeah, has to be the boy, because the boy is the only person touching the chalk, right? So the boy is providing the energy, the boy is doing work. So this additional energy came from the boy lifting it up. Am I going too fast? Okay. Now a girl is standing at the 10th step. She has a mass of 50 kilograms. Then she walks up 40 steps, each of them 15 centimeters high, to reach the 50th step. At the end, what is the height of the girl above the ground? So just multiply 50 steps times 0.15, you get 7.5 meters. That is the height above the ground that the girl is at. Gravitational potential energy given by mgh. So show me your formula first, then your substituted values. to get 3,750 joules. That's her gravitational potential energy. So when she moved from the 10th step to the 50th step, she did work. This is shown by a change in gravitational potential energy, which is also given by mgh, the height of 40 steps. So between your 10th to 50th step, she gained 3,000 joules. And this must have come from the girl doing work against gravity. She is bringing her weight upwards from the 10th step upwards to the 50th step. So the direction of force is upwards. The direction of travel is also upwards. Alright, who is still copying your corrections? Now, moving on, you can go and watch the video, okay? Worksheet 6E. Hopefully we can cover 6E and then move on to 6F. Mr. Tan's class, do you have your 6F with you? Also hand in. Went through already. 6F also. Okay, never mind. 6E now. Pass. Worksheet 6E. Jonathan. Yes. Stop talking. Okay. So what do we mean when we say machine A has more power than machine B? Power is given by work done over time taken, which is also a change in energy over time taken. So when we say A has more power than B, we say that A can do more work than B in the same amount of time. Or you can look at it the other way. A can do the same amount of work as B in less time. So we conclude that A has more power. So who is the most powerful in this class? Afiq can do the most work in the least time? Are you sure or not? Okay, question 2. Okay, enough. Question 2. Say the definition of power. Just copy from your textbook. It is the rate of work done, the rate of energy conversion, and the formula is W over T or E over T. Take note that W over here refers to work done, not weight. Okay, this is not weight. I also told my class that this phrase, rate of, most of the time it refers to dividing by time. So when you see rate of change, most likely it is divided by time. That is the formula. Okay, SI unit for energy is also in joules. SI unit for time is in seconds. So for B, Joule, for C, Seconds. What is the symbol for SI unit for joule? Capital J. Okay, you must know the difference between SI unit and symbol. So what is the symbol for the SI unit for time? S. Okay, and the symbol and the SI unit is second. Okay, energy conversion, you can do this yourself. This is part of your first chapter. All your milli, mega, kilo. Just do the corrections quickly. Now, question 5. An electric lift can carry a load of 10,000 newtons. 10,000 newtons. How much mass can it carry up? If it can carry a load of 10,000 newtons, then on Earth, what is the mass that it can carry? 1,000 kilograms. Okay, that's 1 ton. Quite a lot of people. 1 ton. Okay, it can carry this load up 20 meters in half a minute. What is the power of the lift? So power is equals to work done over time taken. Work done is given by force times distance moved in the direction of the force. So we are exerting a force upwards. It is traveling upwards. So 10,000 newtons times 20 meters divided by time taken in seconds. So answer will be rounded off to be 6.7 kilowatts. Okay? Your unit for power is watts, W-A-T-T-S. So again, we have another W over here. Do not be confused. This W is for work done. This is for the unit of power. Question 6. A food mixer. Power rating 800 watts. How much energy does it use when you switch it on for 50 seconds? So, power is equal to energy change over time. So, energy change will be power times time. You get 800 times 50, 40 kilojoules. You can go home and check out your appliances, your fridge, your aircon, and you go and calculate how much energy you're using just by keeping them on. Okay, 6F. Did I give you all 6F? Okay, so those from my class, you have 5 minutes now to work on worksheet 6F.